Hi, welcome to a new session of Circuits and Networks. In today's class, under two-port networks, we are going to see the conversion of ABCD parameters, Y parameters, and H parameters, either in terms of Z parameters or Z parameters in terms of other parameters. So for that, we are going to see from the basics what we have learned in our past classes, that is in past 15 classes. The Z parameters are given by Z11, Z21, Z12 and Z22, and this is framed from equation 1 and 2 based upon the Ohm's law. Then we have Y parameters, which is given by equation 3 and 4. You can see Y parameters is nothing but the admittance parameters, which is nothing but the inversion of Z parameters. And then we have shifted to ABCD parameters given by ABCD. So the positives of ABCD parameters are also known as transmission line parameters. And hybrid parameters, generally hybrid parameters, we are going to see their applications in the branch of ECE engineering, that is electronics and communication engineering. So equation 1 to equation 8, these are the standard two-port network parameters, what you are supposed to learn from two-port network concept. Now another thing what we have to remember is the condition of reciprocity and condition of symmetry for these four parameters. For the first Z parameters, the condition of reciprocity is given by Z12 is equal to Z21, and the symmetry is given by Z11 equal to Z22. And similarly, the Y parameters and the transmission line parameters and hybrid parameters, these are the conditions for reciprocity and symmetry respectively. You need to remember these formulas which are helpful to give an answer for 2 marks type of questions or fill in the blanks type of questions. Now another important factor is the conversion of other parameters in terms of Z parameters or Z parameters in terms of other parameters. So for that I have framed these formulas you can see over here. I have Y parameters, ABCD parameters and H parameters. Once I have done with Z parameters, so these are the formulas. This derivation already we have seen in our past class. You can look into the class 6, 7, 8 for these derivations and for these concepts. And similarly, you observe the Z parameters. If at all you want to obtain the Z parameters in terms of admittance parameters, same equation you can see here. The delta Z is replaced by delta Y, Z22 is replaced by Y22, minus Z12 is replaced by minus Y12, and vice versa. You can see the formulas for the ABCD parameters in terms of Z parameters. You can see the formula, you can relate with the formula, and hybrid parameters in terms of Z parameters, you can relate the formula. If at all you are able to recollecting the formula in this fashion, then it would be easy for you to convert any kind of network or circuit in terms of Z parameters. Anyhow, we are going to see the basics what we have seen in our past class. So here we have to obtain the Z parameters and then we have to derive the Y parameters, ABCD parameters, H parameters. For that, the standard form, we are going to open circuit the output port, which is nothing but this port, and the rest of the network is going to be obtained in this fashion, that is 1, 3 are in series applied to input voltage source V1 supplying current I1, and this gives you the value of V1 is equal to 4 I1 because 3 plus 1 becomes 4. Now Z11 will be equivalent to 4 ohms when I2, that is a port 2, is open circuited. Similarly, the V2 is a measurement of voltage across 3 ohms, that is obtained to be 3 I1, and Z21 will be equal to 3 ohms. So equation 4 gives the value of Z21. Now when you take the input port and open circuit it, then I1 will be equivalent to 0, and this is how the figure 1b is obtained from figure 1. And here you can see the anti-clockwise direction of the current is shown because V2 is energizing the 2 ohms and 3 ohms in series. So V1 is a measurement of again voltage across 3 ohms. So that gives you the value of V2 is equal to 5I2 because 2 and 3 are in series, and V1 is equal to 3I2. With this you'll get the value of Z22 as 5 ohms and Z12 as 3 ohms. So equation from 1 to 6 you can reframe, and the Z parameters are obtained to be 4, 3, 3 and 5. Now the delta Z, you can get the value of delta Z which is obtained to be Z11 multiplied with Z22 minus Z12 multiplied with Z21. So it will give you the value as 20 minus 9, that is 11. Now with this I can get the value of ABCD parameters with the table conversion. So I'm going to get the value of ABCD, which is equal to 1.33, the value of A, C value is 0.33, B value is 3.67, and D value is 1.67. Likewise, we can calculate the H parameters and we can calculate the Y parameters. So these are the results which are obtained based upon the formula. Now what happens if at all we want to get the solution from another way? So this particular method is known as substitution method, equation substitution method. Here what I'm going to do is I'll apply KVL in clockwise in loop 1. So and KVL in anti-clockwise in loop 2. So here you can see I have taken two loops with the directions of the V2 and V1 and I1 and I2. I have taken the directions of clockwise and anti-clockwise in this fashion. Now applying KVL, I'm going to get minus V1 plus 1, I1 plus 3, I1 plus I2 equal to 0. I can reframe the equation as V1 is equal to 4I1 plus 3I2. Again, applying anti-clockwise direction of KVL will give you the value as minus V2 plus 2, I2 plus 3, I2 plus I1. With this, you'll get the value of V2 equal to 3I1 plus 5I2. Now you can see these two results are compared to the standard equation of impedance parameters 1 and 2. Then I'm going to get the value of Z is equal to 4, 3, 3 and 5. Now this is the same result what we have obtained from the previous method. Now checking the condition for reciprocity and symmetry, you can see here the value of Z12 is equal to Z21. Hence this network satisfied the impedance parameters in terms of its reciprocity, whereas 4 is not equal to 5. So this is not a symmetrical network in terms of Z impedance parameters or Z parameters. So that is the conclusion what we have made from the given values of resistors. Okay. Now, what if I want to find out ABCD parameters from Z parameters? Already we have derived the Z parameters here, which is given by equation 1 and 2, and equation 2 is rearranged as equation 3. Like you can see, I have taken 3I1 and I have shifted this 5I2 onto the left side, so it becomes V2 minus 5I2, and I want to get the value of I1. Then I1 will be equal to V2 by 3 minus 5 I2 by 3. This I'm treating as equation 3, and I'm substituting equation 3 in equation 1. Now equation 1 you have I1 here, so that is substituted by 3 equation. So you can see here 4 V2 by 3 minus 5 I2 by 3. Now this gives you the value of V1 is equal to 4 V2 by 3 minus 11 I2 by 3. From equation 3 and equation 4, and I'm comparing it to the standard ABCD parameters equation. You can see which is given by equation 5 and 6 here, V1 I1, which given by AV2 minus BI2, CV2 minus DI2. So I'm just for sake of understanding, I have replaced ABCDs with colors A, B, C and D. Now comparing equation 5 with equation 4, you can see we have A is equal to 4 by 3 and B is equal to 11 by 3. And comparing equation 6 with equation 3, I'm going to get the value of C as 1 by 3 and D as 5 by 3. Now with this, I'm going to get the value of transmission line parameters given by ABCD, which is equal to 1.33, 3.67, C value is 0.33 and D value is 1.67. Now the same result we have obtained when we have approached with the formula based concept. Now this solution is based upon the equations framing by rearranging them and substituting in the given equations. So this is a substitution method of the equation. You can employ the technique for other parameters also, and you can check the condition for reciprocity and symmetrical. Here the given network in terms of ABCD parameters it is reciprocal, but in terms of symmetry it is not, because A value is not equal to D. Now as a homework, you please comment in the chat box whether you are going to obtain the value of H parameters and Y parameters by substitution method or not. The answers are given to you. Just you have to apply in the substitution methods. Just give a logic of I2, concentrate on I2. 5I2 is equal to V2 minus 3I1. Then I2 will be equal into V2 by 5 minus 3 I1 by 5, and substitute in equation 1 and tell me whether you are able to obtain the value of H parameters or not. And similarly, take the matrix inversion method for Z parameters and obtain the Y parameters, and comment in the chat box whether you are able to obtain the result or not. So that's all for today's section. Thank you for listening to this class. Please share this video among your friends, subscribe to this channel, and press the bell icon for the future notifications. Thank you.